Recording in progress. Alright, so I'm going to start explaining. Pandas now. So, introduction to pandas. We have introduction to pandas, series, data frames, missing data, group by, merging, joining, and concatenation operation, data input and output. Now, pandas, as I'm going to come again about introduction to pandas. Pandas is a very powerful tool or library for data analysis. Okay, and I don't know how many of us are familiar with using Excel, that is the advanced Excel for data cleaning, visualization as the pivot chart, pivot table, slicer, and so on. So, but before we move on, I hope we are all together with me in the same, that is with this notebook. If you don't have it, just look for pandas updated. You should have it or send it to us. Okay, now we have import pandas as PD. Don't forget we've discussed NumPy. Before you go on with pandas, you must make sure you've treated NumPy. NumPy is a library for arithmetic or mathematical calculation. That is, this library is very essential when you are trying to work with small data, that is small mathematical data, like trying to do cos, sine, cosine, or logarithm or matrix or arrays. NumPy is the best library for it. So now we're working with import pandas. Now over here, all you just have to do is to run it by clicking on Shift Enter on your keyboard, or you could click on Run here, or you could press here to run. Okay. Now we could check the version of pandas we are using. So depending on what version of pandas you are using, it's good to use the updated version. Now you could remember where we talk about the list in Python crash course. Okay, so ARR is what? A variable, that is a container. Don't forget Python crash course, I told us what a variable is. I said a variable is a container. Okay, take for example a bottle of water is a container holding a substance called water, which could be either solid or liquid. Okay, so ARR is a container holding these items, that is 0, 1, 2, 3, 4. Okay, and each of these items, how do you identify a list? A list has a square bracket, that green box you see there. Okay, so this is a list like this. So now we could convert this list to a series. Okay, now when I mean a series, I'm saying it's going to print out whatever is in that list with the index. Okay, so note that everything at this side, that is this 0, 1, 2, 3, 4, are called the index. Okay, so when I put in s1 equals to pd dot series, don't forget we are working with what library currently? We are working with pandas, that is import pandas as pd. Whatever we'll be using throughout this class is PD, okay, or NP. Either if we want to work with NumPy, we work with NP. If we want to work with pandas, we work with PD, okay. And I told you we'll be working with all these functions. That is, we're looking at data frames, series, missing data, and so on. Okay, so moving on, we have s1 equals to pd dot series. Then we call in the ARR, that is this list over here. So when we run the Shift Enter, you have this. Now let's work with another example. Example 2, order. Order equals to 1, 2, 3, 4, 5. Okay. Now 1, 2, 3, 4, 5 is like an item that is put inside the order, and order is a container holding them. Okay. And now S2 equals to PD dot series of, then we call in the order here. Now this order, when printed, that is S2, you could also say print, S2 here. Okay. Then when you run it, you have this. Now don't forget 1, 2, 3, 4, 5 is 1, 2, 3, 4, 5. Then all these here are called the index. Okay, don't forget. And don't forget indexing starts from 0. Okay, every index we have always starts from 0. Okay, all indexes start from 0. All right. So now let's using an index. Okay. Now when we say pd.series, it automatically generates an index for us for anything for this list. Now let's give our own index instead of this um instead of Jupyter to generate the index for us. Okay, for example, if I say dot 5 dot 10 comma 12 20 28 comma, I'm just adding different numbers and I run this. Now can you see it automatically generates index for them too? That is 6, 7, 8. But don't forget, it's always start from 0. Okay. So let's now create our own index. Now we are saying ser1 equals to pd.series 1, 2, 3, 4. Now 1, 2, 3, 4 is a list. Don't forget how to identify a list, a square bracket, comma index. Now this index here, has all this. That is US, Germany, USSR, Japan. Now all these are called index. That is, we said index equals to this. So when we run this now, we have US 1 equals to US, 2 Germany, 3 USSR, and 4 Japan. Okay, so everything here is also the index. Same thing applies here, the index. Or let's change this to 10, 25.
Why do we have data type at the output integers is for why?
Yeah, that's because whatever we have in here are called integers, right? Okay, so let's try something. Let's try to put 1.5, 2.5, 5.5, and 4.5. And when we run this, we have float. Can you remember the three types of index I told us when we were doing Python crash course? I told us we have integer, that is whole number. We have float, which is decimal, that is with the point. So these numbers fall under decimals, that is they have points in between the numbers. So that's why it's giving us float. Why these ones are whole numbers? That's why we just have the data type as whole numbers. Okay. All right. So now let's say, so now how do we retrieve an item? Okay. Let's work with two. As I want to work with this one here, this variable. So if I say ser2 of US, it gives me 1.1. That is, I'm accessing this value, that is all these items. Don't forget about the indexing I taught us during Python crash course. Now all these items, I could access them based on their index. Okay, now I know the index of 5.5 is Italy. The index is Italy, right? Now, how do I access Italy? How do I access it? All I just have to do is to put the index, and the index is Italy. So all I have to do is to copy this index and put it here. Okay. So when I run it, I have 5.5. I could do the same thing for Japan. Okay. I just have to do this, paste it here, and I have 4.5. So what if I now try to access the number, like I try to access Italy or I try to access Japan with the item? It's going to give us an error, okay? Because it's give us an error. So this is it's throwing us an error because we can't access an item. So we can't access an index with an item. All these are called a list. You can also call them an item. So you can access an index with an item, but you could access an item, that is, you could access all these items based on their indexes. All these are just like, let's say this is the actual parents, then these are the children. Okay, so if you want to have access to the parents, you can identify them based on their children. So Germany is a child to 2.5, okay, and Japan is a child to 4.5. So 4.5 is the parent to Japan. You could either do it that way. So let me just press Ctrl Z here around this. Okay. So now you could also do some additions. Okay. That is, you could say, don't forget we have done SER1 and SER2. So when I say SER1 plus SER2, when I run this, I have this. Okay. That is going to add USA plus USA. That is 1 plus. It's going to have Germany plus Germany, USA plus USA, um, USSR. Now, if you notice, Italy and USSR have what they call NAN, right? Now, the reason is because what this stuff is doing, that is what this first SER1 and SER2 is doing, is that they are adding based on the index. Okay, for example, we have USA here, we have USA here, we have Germany here, we have Germany here, we have USSR, we don't have USSR here. We have Italy here, we have Italy here, we don't have Italy here, and we have Japan here, and we have Japan here. So USSR and Italy are two different things. So they can't be added together. Okay? So that's why Italy and Japan is giving us Italy and USSR is giving us NAN, and NAN means not a number. Don't forget that, not a number. For example, you could see NAN in a data set. For example, you are given a data set in, let's say, a bank sector you work for, give you a data set. Now they will give you a data set and there will be a lot of missing values. We'll get to missing values later. That is, data are some values or some item or some data are missing where they are supposed to be. Like they are empty. Let me just put it that way. Okay. So they are usually represented with NaN or null. That is, or they are usually blank. Okay. But let's try something. What if we now say, okay, USSR, right? Now let's see if we're going to have an error. So I have this, I have this, I have this, I have this. Now I don't have an error. Reason being that the index in SER1, the index in SER1 is same as the index in SER2. So that's why I don't have an error. So let me just do Ctrl Z here. Okay, I run this back. Okay, so I have an error. So I have NaN. Alright, you could also do subtraction, also do multiplication. Okay, either way you do it is fine. Okay, now let's work with NumPy. So if you haven't worked with NumPy library, please, I encourage you to do that and to watch the tutorial video I sent already. So we'll be working with NumPy, that is this library here. We imported it already. So what we'll be working with is NP. Okay. So now for NP, we said S3 equals to NP dot array of ARR. Don't forget we've created something called ARR. Let me run this here and print ARR. When I run this, I have 0, 1, 2, 3, 4, 10. That was because I added it. This is where ARR is. I added this last element. So let me just remove it. Okay, let me run this. Okay. So now for ARR, I have 0, 1, 2, 3, 4. For ARR, I have 0, 1, 2, 3, 4. Okay. Now, when I say that is, I want to convert this list. Don't forget this is a list. How do you identify a list with a square bracket? I convert this ARR to an array. And how do you identify an array? An array always say array. So this is how you identify an array. Once you just see array, this, you know this is an array. Okay. If I say S3 equals to NP dot array ARR, that is, that's converted into an array for me. Okay, so now there's difference between this guy and this guy now. One is an array and one is a list. Okay, now let's do both list and both series and array. Now say labs. Labs is a container holding these items ABC, and ABCD has a data type of what? A string. Don't forget we said a string could be single or double quotes. Okay, then my data is a container holding 10, 30, 40. 10, 30, 40 are items also. They're also a list. Okay, then when you say ARR, okay, equals to np dot array my data. Okay, then now say D. We've talked about dictionary, right? We said dictionary has a key and a value. Okay, can we remember where I said we have E for egg, then we have B for banana? That is, you could access, I'm just giving an example according to the Python crash course that we've done, if you could remember. Now for this one, D equals to A, that is, A is a key representing 10, and B is a key representing 30, and C is a key representing 40. Okay, so when you print ARR, let me change this guy to ARS. Okay, so I say ARS, let me change this guy to ARS. So I say ARS equals to np dot array my data. My data here is what? 10, 30, 40. So when I run this, guy, I have 10, 30, 40 with an index of what? 0, 1, 2. Don't forget this by default. When you see a list like this, you should know their index. The index is always starting from 0. That is, 10 has an index of 0, 30 has an index of 1, 40 has an index of 2. Okay, then when we talk about, when we now say pd dot series D, D is
What
what?
is the usefulness of the dictionary in putting that dictionary in that command? Yeah.
Yeah, the dictionary is like, okay, yeah, we'll work with it. Like, we want to convert this dictionary to a Pandas series. That is, that's where we did pd dot series of D. That is, now ABC now here is now the index. Can you see we have A, B, C? Don't forget we said normally the index of a list is like starting from 0, 1, 2, 3, right? Now for dictionary, the index are the keys, okay, because it's with the index you use to find the item or the value. Don't forget I said a dictionary has a key and a value. 10 is the value, A is the key, B is the key, C is the key. Then 10, 30, 40 are the values. Now the index are also the what's it called? The keys. The index are the keys. So now if you run pd dot series of D, you get 10, 30, 40. So now in summary, all I'm just trying to say is, if for example you don't know the index of something, okay? So let me just give an illustration down here. Let's say I have an array list. Let me just call it a list. I have a list of items, okay, like 10, just putting random numbers. So in case, so let's say I have a list of, let's say about 10,000 items like this, okay, and I don't know what the index of most of them are. Like I literally don't know the index. I'm trying to figure out how can I get the index. Okay, now let's say I want to get the index of this guy 292. Okay, I want to get the index of 292, and I don't know how to go about it. I don't know how to go about, like, to get, all just I have to do is to say pd dot series of list, and when I run this, okay, sorry, there's a comma there instead of a full stop. Okay, so now I could say, okay, 292 has an index of what? 7. Okay, or I could do it manually. I could do it manually to stress myself and say this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, and this is 9, this is 10. So I could stress myself with this. But if I don't want to stress myself, I could just put everything in a list by separating them by comma and find the index. Okay. Now it's with the index you could use to work. That's just an example. Okay. Now let's talk about PD dot series of labs. Don't forget labs is equals to ABC. Labs is equals to ABC. Okay. If I say PD dot series of labs, index equals to my data. Now what's index? What's my data? My data is 10, 30, 40. Okay. So when I run this, I'm having 10, 30, 40. But if I remove this, that is, if I sorry, let me cut it. If I remove this and I run this, the index of ABC is 0, 1, 2 by default. Let's come here. Let me say PD dot series of labs. When I run this, I have index. Can you see what I have here is the
I
same thing?
noticed that the series, you always start the series with capital S.
Yes,
That's
yes, that's how
the
it's
most.
written. If you put small
Okay.
letter S here, it's going to give you an error because by default, that's how it's written with capital letter S.
Okay.
Yeah. All right. So if you see here, the difference there's no difference between what I have here, right, and what I have above here. There's no difference. Okay. So everything is just used to show when you see PD dot series, it's just for you to get the index of a list or of an array or of a yes of an array. So now let's work with order. Now this don't forget order is a what data type it, and this order that is this variable is a list, and when you say and we have BO also a list. Now you could say S3 equals to PD dot series of order. Now when I say PD dot series of order, what am I trying to do? I'm trying to get the index of everything in this order. I'm trying to get the index of it. Okay, and the index is the same thing as the actual value. So what if I now change this place to 6? And I run this and I run this. So 6, 1, 2, 3, 4, 5, 6. So 6 has an index of 0, 1 has an index of 1, 6 has an index of 6. Okay. Now when I say S4 equals to PD, don't forget we have S3 equated to this guy. So S3 is the container holding everything here. Holding everything here. S4 equals to PD dot series of BO. Now, when you print that, you have the index of you get the index of these guys that is 0 to 6. Okay, so when you say PD, you say S3 dot add S4. So what it's doing is saying the value of S4 here, value of S4 here, add it plus the value of S3 and S4, add the values together. So when you run this, okay, so when you run this, you will have this, okay, you will have this. Now in this case, don't forget over here, where's our aspect? This place was adding these two S1 and S2 when we did S1, SER1 plus SER2. When we did SER1 plus SER2, it was adding based on the index, right? If you could remember, you could go back and watch again. SER1 and SER2, they were adding based on the index. Okay, that is USA plus USA. Yes, there's USA here, there's USA, add it. There's Germany here, there's Germany here, add it. USSR, there's no USSR, don't add it. Japan had it. That's why we have these guys. That's why Italy has NAN and USSR has NAN. Okay, so when you come over here and you say S4 and S3, this is S4, this is S3. When you add it together, you are going to have this. Now, it's what it's doing it is adding the values, not the index. Okay, it's adding the value, not the index. That is, it's saying 6 plus 1, which is 7, we have here. It's saying 1 plus 2, 1 plus 2, which is 3. It's saying 2 here plus 3 here equals to 5, and so on. Okay. Then we have subtraction. You could do dot sub, you could do dot multiplication, you could do dot division. Okay. Either way, you could also do print. Okay. It's also called this mean median mode. Okay. You could say S4 dot median, and S4 dot median. Where is S4 here? S4 dot median is 4. Okay. That's why we have 4.0. S3 dot max. Sorry. X3 dot add S4 dot max. So when you say x3 dot add s4 dot max, max is 13. That's why we have 13 here. That's why we have 13 here. And dot min definitely 0. That is dot minimum. Minimum, maximum, then the median. Median is like the middle number. Okay. Now let's look at data frame. Now there's something called data frame. Don't forget we've talked about dictionary. Please, if you don't understand what dictionary is all about, please go back to Python crash course. The video is on the WhatsApp group chat. Okay. So what dictionary is that it has a key, it has keys and values. Okay. So with a dictionary, you could create a table, and that's what we're going to do here. I told you initially that before we start working on big data, like large data, as a data analyst or data scientist, you have to work with small data first. That is, you need to work with a small quantity of data to understand how it is done before you could actually carry a real life data and say, okay, I want to work with the real life data. Okay, so now we have what we call a container called fat, and fat is holding a dictionary. A dictionary has a key, has keys and values. As you could see here, I said there's keys and there's values. Okay, so now we have company, which is a key, person, sales, rate is a key. Then the values are like what is going to be inside the entire set. So you could take keys as column, then you could take values as row. Okay, a column or rows. Either way you say it is fine. Column, rows and rows. Okay. So now when you print fat, you're just going to have it like this. If you say fat, you just have it like this. But if you now want to convert it to a table, an actual table, you will see that you create a variable bob and you say pd dot data frame. Okay, then you put in fat. Okay, pd dot data frame fat. So now you have something called bob. Bob is called what? A container. So bob is the one that gives us this entire table. Okay, so let's run from the top. We have this guy, this guy. Okay, okay. So now have all this in view. Okay, so we could say, so Bob is the container holding this entire table, as I said earlier. Okay, so now I could say Bob sales. So if I say Bob of sales dot max, what am I saying? Give me the maximum sales here. When I run this, I have 200. If I say Bob dot sales dot main, I'm saying give me what? The minimum value, which is 100. Okay, and I say Bob dot max, that is, I'm not specifying the actual column to give me, that is the actual column to give me, right? But it's going to give me the maximum column. That is, it's going to pick from each of the how am I going to say it? It's going to pick from each of the company, the sales, the person, and the rate. Okay. So if I say dot min also, it's going to pick the minimum. Minimum in the sense that the length of the length of the word, the length of, like for example, for this row now, I think for this row, Google Sam 20 rate. The maximum for rate now, the maximum is 33, the minimum is 14, right? For sales, the maximum is 200, the minimum is 100, right? For for person, okay, in terms of, let's see, name, in terms of name, okay, in terms of name, Sam, okay, why did he pick Sam? I have no idea. Okay, but let's look for company. For company, the list based on the length, oh, the minimum for company is FB, that is the length is just 2, and the maximum is Microsoft. I think it takes it alphabetically, but regardless of that, you could just discard that. But the goal is that you pick a colon that interests you and probably check the this thing. We could cut here and put person. If you put person, you're going to put Sam. Okay, just the same way we have Sam here as the maximum. Okay, so let me just change this back. Okay. So we have pd dot bob dot count. Okay, bob dot count is going to count the number of each items. Like for example, we have three um three rows, like three people on this, that we have Google, we have Microsoft, and we have Facebook, and each of them have three items. That is just one, two, three. We have three sales, we have three rates, we have three companies, we have three persons. Now we could use a function called group by. Now group by is going to specifically group by a particular like colon. Okay, don't forget this is a colon, that is company person company sales rate are column, while um, sales like these are rows. All these places highlighted are rows, that is like this, they are called rows and columns. You need to understand that, because as a data analyst you need to know the difference between a row and a column. Okay, so we could say comp equals to bob dot group by person dot minimum. So it groups by the person with the minimum, and the minimum is 100, but the group by minimum based on sales. Okay, person with the minimum sales is Amy, so that's why I give 100. Then if you say, let's put dot max, okay, dot sales now, dot sales is groups by sales. Okay, now sorry, for this one it's different actually. For this one, it picks it alphabetically. That is, we said group by person, and the person's name that comes first is Amy, that is with letter A, followed by C, followed by S. Now for sales, if you say group by sales, the list is 100, 120, 200. If you now say com dot max, okay, now it gives you a maximum of um sorry, so from this table now, because com is the container holding this, if you say dot max, it gives us a maximum of Microsoft as max and Sam and the rates. Okay, that is Sam is over here too. If you see that the sale is the maximum sale we have is 200, the maximum person we have, that is Sam, based on like If min starts from Amy, then the max should be definitely be Sam. If minimum sale is 100, the maximum is 200. Okay, so that's understandable. Just as we have min, I told you Facebook based on the letters. Amy, that is, it started with letter A, which is the minimum. Then if you see dot max, it's going to definitely start with the last person. That is based on based on number A, B, C, D. Okay. So now let's talk about mean. We have mean. We say the mean is going to find the mean rate. That is going to add 14, 33, and 20. 33, 14, and 20 together and find the average and give you the mean value. Okay, now you could say dot max. You could say STD, that is standard deviation. Okay, to give you the standard deviation. Now we could also say dot describe. Now when you say dot describe, you are trying to get a brief summary of your data based on the mean. You know, the mean we said dot mean, now we have 22. We have, when we say STD, we have 9.6. We still have the same value here. We still have the same value here, but just for only rate alone. So instead of doing it like, instead of you saying dot mean instead of saying dot mean dot max dot this, you could just say dot describe, and it's going to give you everything here. See, dot max is 300, dot mean is 14. This is just for only rate though, because that's the only number it could actually work with. That's the only numeric number it could work with. You could also say dot describe dot transpose. Now when they say transpose, that is what is on the horizontal is now on the vertical, and what is on the vertical is now the horizontal. They just toggle, that is they just swap. Rate came down and all this here came up. You see, they're both the same thing. Then you say
Excuse me.
yes.
Why did you pick the rate when you are describing? Why not any other column?
I
Why
don't
did you pick rate by default?
rate because rates are all numbers. Okay, like it's like the target.
Okay,
Yeah, it's like the target
okay, I
column.
get it. I
Yeah,
get it.
if you
I
are
get it.
okay, sir, if you are actually to work with, let's say, a different, like a data set that has, don't worry, when we go further we're going to work with data sets that has different columns. Let's say some will have profit and margin, loss, or bonus. It's going to give everything, but this is just a mini data set. That's why it's working with that. So let's now move to concatenation. So there's something called concat, shorten from gotten from concatenation, that is to join. Okay. Don't forget we've been working with S1, S2, S3, and S4. Let me scroll up a little for us to see. So this is S1, S2, S3. Yeah, S2, S3. Where's S1? Okay, S3, S1. So we have S1, S2. Hope you could see S3. This is S3. Where's S4? This is S3. This is S4. So we've been working with S1, S2, S3. So you could just use, like, let's say you want to join everything together. You could say pd.concat S1, S2, S3, that is join. All it's just going to do is just going to join the values of S1. So S1, S2 started from 0 to 4. S2 started from 1 to 5. S3 started from 0 to 6. And S4 started from 1 to 7. Don't forget the index are different. Okay, the index of S3, the index of S1 is different from the index of S2. So S2 is like this. The index of S2 is different from the index of S1. So now let's move to margin. Now for margin, it's a function that allows to merge data frames together. Now don't forget that the table we created, don't forget data frame allows to convert a dictionary to a table. Okay, so now look at this table, look at this dictionary. Identify a dictionary, a square curly bracket that has keys and values. Okay, so keys A1 and AB, then values are all these ones. This is a value, this is a value, A2, A3 is a value, B0 to B3 is a value. Now, how do we join the two of them together? Let's say we want to join a table together. How do you join it together? All you just have to say is to say pd.merge RIG, LEF, on keys. So you join them based on their keys. That is, we have key zero, we have key zero, K1, sorry, K1, K2, K3. Okay, that's based on their keys. Okay, so we have K1, K0, K3. Don't forget the K1, K2, K0, K1, K2 is the same thing as K1, K2, K3 here. And the keys are the same thing, that is, the spelling are the same thing. What if we decide to remove FC and we run this and we run this? We're going to have an error. Okay? Oh, that is, when we run this now, run this, we have a table. Hope you understand what I did. Good. So now you could do the same thing for this one. Left equals to pd.data frame. Don't forget what we're using here. We're using data frame. That is, we want to convert a dictionary. This is a dictionary. We want to convert a dictionary to a table. So all you just have to say is, like, for example, we have K1, we have K2, and K. So you see K1 here, like this, is the same thing as the K1 here. Okay, but K2 is here, but there's no K2 here. So it's just going to create another column for K2. So that's why we have K2 here. So it just, and we have all the data in there. Okay, so let's run this. Let's run this. Okay, so now let's talk about joining. And the difference between joining and merging. Merging, you are merging two data frames together. Joining is more of like combining a column of two potentially different index data frame into a single result data frame. Okay, don't forget the index of LEF is the same thing as the index of um, RIG. That is, keys here are the same thing as the keys here. Okay, so but for this one, there are different things entirely. That is for joining. Okay, now we have A is a key here, B is a key, C is a key, D is a key. Okay, but the index are the same thing. Don't forget, for this one, the keys are the same thing. That is, we have key 1 here, we have key 2 here. We have, okay, for this one, we have keys here. That is, the keys are the same thing. We have keys here and we have keys here. Okay, but for this one, we have the same index here. The index, that is, we are creating an index here. The index here are the same thing. So index is the same thing as this. So when you say left dot join right, have this. So it's just going to merge the left data frame with the right data frame. And you see, when you say left dot join right, you have the same thing. Okay. Now, when you have NaN, don't forget I told us NaN means not a number. So that is between K1 and K1, between K1 here and C, there's no any value. Okay, that's why we have NaN. That is, there's a blank space there. Okay, so now let's talk about operations. Now df equals to bob, df.ed. Can you remember this data? Yes. We worked with this data above, so you could scroll back up if you want to see it, but I already called it here. df equals to bob. The name of the bob is actually, so using an existing data set, we've created it at the top, which is this. Okay. So you could, now when you have a data set, let's say you are given a data set in an health sector to analyze patients based on the patient taking their viral load, or patients that have, or let's say COVID-19 data sets, for example. Now, how do you analyze and visualize COVID-19 data sets? Okay, now we have df.ed. Now, df.ed is telling us the first five, it's going to give us the first five data. Okay, but because this data is limited, that's why it's giving us, because actually this data by default is is 3. Yes, if you could remember, it's 3. We have just Google, Microsoft, and Facebook. Okay, so if I say df.ed, right? If I say df.ed, I have the first, it gives us the first 5. Okay, but when I put in df.1, if I put in 1 here, it gives me the first one. If I put in 2 here, it gives me 2. If I put 3 here, it gives me 3. If I put in 4 here, it still give me the same thing because the maximum length or the maximum role of this data is just 3. So that's why. But if you don't put anything inside, you could put dot 100, 400 sef. That's depending if the number of rows of your data set is more than is actually up to that extent. Okay. So if you leave it like this and you run it, you have the first file. Okay, we're going to see more. Then you could see the bottom of the data set because imagine having over 1000 rows of data. There's no way you'll be able to see the end and the beginning or the middle. All you just have to do is to say dot head dot tail. So when you say dot tail, it gives us the last two or the last yes. But if you put in like this empty and you run it, it's going to give us the last part. It gives just the way the first 5 is, it's going to give us the last 5 data. Okay. Now let's look at finding unique value in a data frame. Okay, finding unique value in a data frame. Now in a cell in this cells we have 120, 100 and 200. Now if you say df, that is df is the container holding Bob and Bob is actually equals to this data set. Okay. So if you say df of sales, this is how to write of sales. So df of sales dot unique. Unique is a method. Okay, so it's going to return a unique array of data. We'll be working with more advanced data sets later on, but just put this at the back of your mind. Okay, then we have um, df dot n unique. That's number of unique value. So the number of unique value is 3. That is 120, 100, and 200. Then you could do df of company dot value underscore count. That it returns the number of unique value. That's number of occurrence. So Google, that is for company, we have just 3 companies: Google, Microsoft, and Facebook. This is Google, this is Microsoft, this is Facebook. So number of occurrence is just one each. Okay. Now you could do by selecting condition, that is df of say greater than 100 and this and okay or sorry, this is or. Okay, so we have two conditional. Before we move on, let me just put this for conditional, selecting conditional because so we have, I think we talked about it during Python crash course. We talked about and operator, and then we talked about or too, or operator. So for and it's represented with two ampersand signs, while for or we have it as two pipe, okay? Either one or two, either way. So you could, so if you say df, that is either this statement is correct or this statement is correct. Okay. So if you say df of sales greater than 100 or greater than equals to 100, so each of all these sales they are actually greater than equals to 100. But let's just put greater than 100. That means this column will not appear. This column will not appear because it is not greater than 100. The sales, that is the sales, is not greater than 100. Okay, that's why I remove the equals to, so it won't appear. This entire column will not appear, right? Or df of say equals to 120. So let's just put equals to 120. Now equals to 120 is specifically to this guy, to this column. Okay, so when I run this, I have just Google and Facebook, correct? So what if I now put greater than equals to 200? That is, we have sales. That is, sales is greater than 100 or sales is greater than equals to 200. It will still give me the same thing. Don't forget, or operator means that for all, either one of the statements is true, or either one of the conditions are true, is equals to true. I've already said this before, but I'm just typing it for those that don't know. You want to, you could check the Python crash course. This one is saying both of the conditions are true. Have it true. Both conditions are true equals to true. That is, for you to have true, that is for you to have your answer printed, both conditions must be equal to true. But for or, that is for this sign, either one of them, that is, if this condition is true, it's going to print the right answer for you. But for and, this guy, that is, this condition must be true and this condition must be true. Else, it's not going to print out the right condition for you. So let's try ampersand. Let's try and. We'll try and now. And, okay, sorry, it's actually one, not two. I made a mistake. So if I say df of sale greater than 100, that is from this data set, from the sales, which one is greater than 100? 120 is greater than 100 and 200 is greater than 100. So 120 and 200 are greater than 100. True. So that means we have this column here. We have the first column and the last column. Okay. Then we now have and sales is greater than 200. Greater than 2. Greater than or equals to 200. If we just put greater than 200 here and run it, we'll not have anything. Why? Because first of all, sales greater than 100. Now 120, that is this column satisfied. 120 is greater than 100. True. 200 is greater than 100. True. We have true selected. Don't forget we are dealing with what condition? And. Now, they now said for this condition is greater than 200. Sales is greater than 200. Now, don't forget we selected this guy, this first condition. Sorry, we selected this first condition and this last condition. Now it will now still check, is 120 greater than 200? No. So it will not print it. Is 200 greater than 200? No. 200 is not greater than 200. But if we now put greater than or equals to, okay, is 200 greater than or equals to 200? Yes. 200 is not actually greater than 200, but 200 is equals to 200. That's why we have 200 only printed. I hope you understand this aspect. Okay. If you want more clarification, you could let me know. But let me move on. We have